Hello everyone, welcome back to my channel, the IITian Coder. This is the video editorial of all the problems of CodeChef InfInIty 2020 Division 2, rated for Division 2. So let's look at the first problem. So the problem is the one who knows. So this problem was very easy. You are given one positive integer a and one positive even integer b. You can choose these, okay? And you are given an x and a y, and your task is to minimize the number of moves or minimum rounds, and in each round you can do x equals x plus a, like replace x with x plus a or replace x with x minus b, and you need to convert x to y. So what you need to do is basically make cases, okay? So I will show you my code, and in that I will explain to you how I did this. So let's go to my submissions. Let's go to my code. So this is my code. Okay, so what did I do? I first took in x and y, then I made a variable called difference which stores the value of y minus x, and if the difference is 0, then simply 0 rounds are needed. Now there are two cases. Either the difference can be greater than 0 or the difference can be less than 0, right? So suppose the difference is greater than 0, then in that case, if the difference is odd, we can simply choose this one as x or this one as a, whatever is the difference value because it is odd, and we can choose any arbitrary value for b, and we can do it in one round by doing x equals x plus difference, and the value of a is difference. Otherwise, if difference is even, we can never do it in one move. But if difference by 2 is even, that means that we can add a twice. So we need 2 rounds and we can convert x to y. Now suppose difference by 2 is also even, then this means that I can never do this in 2 rounds, okay? So it was all based on parity. Like, you should know that an odd plus odd is always even, and even minus even is even, and even minus odd is odd, and odd minus even is odd, okay? So if you know all these things, then it's very easy to solve this problem because you just needed to find the combinations that lead to the desired result, okay? So this was for difference greater than 0 case. Otherwise, if the difference is less than 0, then that means we can make the difference positive by doing it x minus y. This means that x is less than y and we will need to subtract it majorly. In this case, we were majorly adding, right? A was the dominant factor and this b is the dominant factor. So if it is odd, we can always do it in 2 moves, like choose an odd number a, anything, you can choose it as 1, and now odd plus odd becomes even, so you can choose that b as that even number and subtract it from x and you get the answer, okay? So the next thing you can do is basically, if it is even, then already the difference is even and you can do y equals y minus b, and b is this difference value. So hope you understood this question. This was a very straightforward and very easy question. So I hope you like this question. So please do like, share and subscribe. And let's move on to the next question. So the next question was, okay, so this is the next question, the empire business. So in this question, yeah, there are n persons and each having a share a1, a2, a3, an in this company, and Walter can buy these shares with their minimum sold values. Now what is the minimum sold value? So the minimum sold value of a person's share I with another person's share j is equal to a of j plus mod of I minus j, okay? So let me show you what it is. So suppose I have a array a1, a2, a3, a4, a5 and so on till an, okay? So to find a1, I need to find the minimum value of a1, a2 plus 1, a3 plus 2 A4 plus 3, and so on, because mod I minus j is 0, mod I minus j is 1, this here. For A2, we need to find the minimum of A1 plus 1, A2, A3 plus 1, A4 plus 2, A5 plus 3, and so on, and so forth. Okay, for this it will be A1 plus 2, and so on. Okay, so what do we get in this? Okay, so one thing that we can use here is we can split the question into two parts. Okay, so as you can see, if let's take a sample case. Okay, suppose I have gone till j. Okay, now I have the smallest number here. Suppose it is a2. Okay, now if a2 plus 1, a2 plus 2 is less than a2 plus 2, sorry, a2 plus 1 is less than a3. Okay, because this is the minimum. Like for a3 the answer is a2 plus 1. So if you go to a4, a2 plus 2 will always be less than a3 plus 1, and a2 plus 2 and a2 plus 1 was less than a1 plus 2 for a3, right? So a2 plus 2 for a4 will be less than a1 plus 3, right? But the only dilemma that we have will be for the things on the right. So let's split the question into two parts, a left and a right. We'll use prefix arrays for this. Okay, so a left prefix array will always contain, see, let's start with a1, a2, a3, a4, dot till an. Okay, so a left prefix array, that is L of I, will always contain for the ith value the smallest cost it can have, only using from the left side. Okay, so for a1, from the left side the smallest cost it can have is a1. For a2, the smallest cost it can have always is a1 plus 1 comma a2, like minimum of a1 plus 1 or a2, right? So whatever is the minimum value here, either it will be a1 plus 1 or a2. Now when we move to a3, if a2 is lesser, then we needn't compare a1, and if a1 plus 1 is lesser, we needn't compare a2, because if either a2 or a1, whichever is out of them, like a1 plus 1 or a2, if a1 plus 1 is greater than a2, there is no way that a2 can ever be the minimum j for any of the right parameters. So we always compared the smallest number on the left side plus a constant, that is the mod I minus j value, and and comma this a3. Okay, so I will demonstrate to you this from my code. Okay, one thing, after doing this for the left, we repeat the process for the right. So for a2, we have the minimum value from the left side, we have the minimum value from the right side. In this takes on time, the right prefix array takes on time, and hence the answer generation takes on time. Okay, so let me show you the answer. My submissions. This was a little good. Okay. Okay. So what do? We first take in the integer n. We declare an array. We declare an answer array. We declare a left prefix array, and we declare a right prefix array and a smallest variable. Okay. We take in the values. Now we initialize smallest to 10 raised to power 9 plus 5, which is the maximum value, which is greater than the maximum value that the array can have. Okay. Now, okay. So now what do is we start I equals 0, and so we go from the left hand, and currently the smallest is too high. Okay. So if smallest plus 1 is less than r of I, then the smallest is incremented to smallest plus 1, because this is now the minimum cost that any person can have from the left side. Okay. And the L of I is smallest. Otherwise, if this R of I that we have found, the new value, is lesser than the earlier smallest plus 1, then this is the new smallest, and this R of I will be itself, and we go to the next. Okay. So let me explain to you if you haven't understood it. See, first we go to A1. A1 is minimum. Good. Move on. Now I need to compare between A1 plus 1 and A2. So if A1 plus 1 is lesser, then A2's values is A1 plus 1, and a new smallest, that is this value from the left side, will be smallest. Okay. Now we go to A3. Suppose smallest plus 1 is lesser, then here put smallest. Otherwise we put A3 here and put smallest equals A3, because for the next this value should be considered. Okay. So basically you can change this loop to L of I equals minimum of L of I or L of I minus 1 plus 1, right? So this loop will be minimum of L of I. I will write it down for you. Minimum of L of I minus 1 plus 1 comma L of I. Cool. So this is what has to be done. Same, do this for the right. Go to I equals n minus 1. You can choose a 1 indexed array or n indexed array. This should be actually n minus 1, but it is C++ GCC 17, so it doesn't give any error, and the question passes the test cases. So you compute the same thing from the right. Now after computing this from the right, do one thing. Yep. Go from I equal to 0 to while I is not equal to n, and then just print the minimum value of L of I or R of I. So the minimum would be for A of 4, as I demonstrated, it will be either minimum cost from here or the minimum cost from the right side. So this gives us the answer, and hope you understood the solution. This was a little difficult to explain because it was pure logic. So if you have any doubts or any requests, please leave them in the comment section, and do like, share and subscribe. And now let's move on to the next question. So this question was Lo Polo Hermano. So this question was very easy. Okay, it was just combinatorics 10 raised to power 9 plus 7 mod. So you're given n horses, you're given the speed of the n horses. So what do you need to do is, you need to find for the ith horse, you need to find the subset with size greater than equal to 2, such that if a race were to be conducted, our horse should finish in the top 3, or else if there are only 2 runners, it should finish in the top 2. Okay, so basically it should be in the top 3. So what should we do? So the first task is, we sort the numbers. Let's clear the board. 5 12. Yeah, so we are given the speeds a1, a2, a3 and till an. Okay, so create a vector which is sorted. Okay, so here it will be AJ and uh, AI and I. Okay, so I can't show, let me show you in my code. Okay, these things are difficult to write until you have the code. Yeah, good. So this is the fast power function with modulus. Okay, so this takes log n time to compute, because as you can see here it is x by 2, so it takes log n time to compute. So we take the number of test cases, then we iterate on the number of test cases, and we take the value of n. Now we create an array, we create a vector, we take in the values, and we associate that particular value with the ith horse. So r of I comma I is in the v vector. You will see its relevance later, and then we declare a position of n hash table kind of array, and we sort the vector. Okay, now what is this position array? So this position array gives us in constant time the position in the sorted array of a ith horse. That means the ith position contains where is the horse situated in the sorted table. Okay, see, v of I dot second is its only original position, original number, that is where was it originally, and this I is basically the position in the sorted array. Now for each horse we compute this, we initialize the answer to 1 and the position to whatever its position is in the sorted array. Now we invert the position, because we need this position now represents the number of horses that are faster than this horse, that are, wait, suppose the position is 0. Okay, in position of I, that means this is the slowest horse. So this position will have the value of n minus 1, which contains the value of all the horses which are faster than this. Okay, so the answer will be power of, sorry, which are slower than this. Okay, because this position contains the number of horses that are slower than this. Yeah, it's a bit tricky because I implemented this and then reversed the code for position. So the simple logic is, so let us keep that this array is sorted. So for A3 I can take, okay, this is an increasing order. Okay, so I can take any of these 2 raised to power n minus 3 horses. I can take any of the 2 raised to power n minus 3 horses. Sorry, this is the increasing order, right? So I can take any of the 2 raised to power 2 horses here, and from these horses I can take either 1, or I can take 2, or I can take 0. These are the 3 cases. So it will be n minus 3c0 plus n minus 3c1 plus n minus 3c2, and the answer will be their multiplication minus 1. Why is this minus 1? Guess what? This minus 1 is because there will be a case when we select 0 horses out of this and 0 horses out of this, n3 and n1c0 and this. So A3 will be the only remaining one horse, and this is not allowed because we have to take subsets of sizes greater than or equal to 2. Yeah, so indeed this position contains the number of horses faster than this horse. Okay, so the position contains the number of horses faster than this horse. So n minus position minus 1 contains the number of horses that are slower than this horse. So I can take 2 raised to power that value as my initial answer. Now I can just say what I told you here, n minus 30 plus this. So it will be, if position is 0, it is this. If position is 1, it will be 1c0 plus 1c1, which is 2. 2c0 plus 2c1 plus 2c2, and this will be NC0, NC1, NC2, all modded by 2. Here this is the NC2. Mod inverse concept is used. I have demonstrated it in a video on YouTube. Please do go and see if you don't understand the concept of mod inverse. And here we subtract that -1. Now if the answer is less than 0, then we increment it by mod, because we need to keep the answer positive, and mod it, which is less than 10 raised to the power 9 plus 7. We print out the answer and then go to the next source. So this takes O(n) time, O(n) log n time. Sorry, there was a sort function here. Yeah, n log n is the time complexity. So hope you understood the solution. Please do like, share and subscribe. I will be posting the solutions of the other 3 questions by tomorrow. So stay tuned and thank you for watching this video.